video series on quadratics. And quadratics is quite a significant topic in Year 10, so you'll find that this video series is quite significant itself. You can obviously dip in and dip out wherever you need to, so please take the time to read the information about what is in each video before you start to watch it. So first of all, a quadratics introduction. I'm going to introduce you to quadratics and the difference between quadratic functions, quadratic equations, and quadratic expressions. So first, let's list out some quadratic expressions here. So we have x squared plus 2, x squared plus the square root of x, 7 minus 3x plus 2x squared, and x squared minus x cubed. Now I did say that we'd be listing out quadratic functions, but not all of these are quadratic functions. So the definition of a quadratic is an expression that has a leading term of x squared and all the terms need to fit within the concept of a polynomial. So first of all, the leading term x squared means that the highest power is a squared and it has to include that power, otherwise it doesn't reach the level of quadratics. The second criteria is that all the terms are polynomial terms. So it can't include things like square root terms or inverse terms like 1 over x or sine x and some other function groups that you haven't learned about yet. So let's have a look through this list. First of all, x is not a quadratic. Its leading term is x to the power of 1, which is a linear function, or a linear expression in this case. X squared plus 2, leading term x squared, and this term is a constant term which fits within our polynomial umbrella, and so therefore this is a quadratic expression. X squared plus root x certainly has a leading term of x squared, but this root x does not fit within our polynomial grouping, so this is not a quadratic expression. Next, 7 minus 3x plus 2x squared has a leading term of 2x squared. It's not at the front of the expression, but it is the highest power, and it doesn't matter where it comes, that's the highest power. It has a linear term and it has a constant term, both of which fit within our polynomial grouping, so this is a quadratic. Put a tick there and a tick here. And our last one, x squared minus x cubed. Certainly looks like a quadratic and it looks like it has a leading term of x squared, but actually the second term is x cubed, which is a higher power, and therefore this is actually a cubic function, expression, not a quadratic expression. So now let's talk quickly about the difference between a quadratic function, a quadratic equation, and a quadratic expression. And this is reasonably important language, but you'll see sometimes even I slip up with it. So you just need to know and understand what the language is, so if you get asked a question, you can identify and analyze that question. So I'm going to look at the same quadratic expression, but then rewrite it as an equation and a function. As an expression, x squared plus 3x plus 1 is an expression. It just has the terms that combine to make that quadratic expression. An equation, on the other hand, is something like x squared plus 3x plus 1 equals 0. So it's become an equation because it's equal to something. It's still a quadratic equation because it's equal to something that fits within that quadratic grouping. It could equal 7, it could equal 100, it could equal x squared. Well, not x squared, it could equal 2x squared, but whatever. As long as it equals something that fits within that quadratic boundary, that polynomial form, then we're fine. And lastly, a quadratic function is something that is like something more like y equals x squared plus 3x plus 1. So it's a quadratic function because it now relates two variables, y and x, and so it's something that can be sketched, something that can be analyzed, something that has multiple solutions within that sketch. And you can see there the different forms, and this is the key part of a function. This is the key component of an equation. An expression is just a quadratic component. Lastly, I just want to introduce you to the first form of a quadratic, and that is that y equals f of x equals ax squared plus bx plus c. Now just firstly, you'll typically see y equals ax squared plus bx plus c. I've just introduced this f of x. It's not really important right now, but it's going to come into this topic a lot. Y and f of x are fairly interchangeable. Y is just our other variable. F of x is saying a function of x equals blah, blah, blah. And f of x is nice because it's really a good way to do substitution. We can now write f of 7 and take x out and put 7 in. So it means the same as y. It has some different little nuances that you'll learn about as we move forward. A quadratic function or equation or expression can be written in this form, and it's really the simplest form. The important thing about this form is it identifies that there are 3 terms possible within a quadratic. So it's got an ax squared plus bx plus c. This is the constant term. This is the linear, and this is the quadratic term. And you can see that there, and we'll refer to those names. Now, a quadratic has to have a quadratic term, otherwise it's not a quadratic. But it doesn't have to have this linear or this constant. If either of those two are missing, or even if both of them are missing, it can still be a quadratic. So there you have a bit of an intro to quadratics, some of the language and some of the ideas.